Hello developers, let's start developing. Today is today to tackle the 10th task of the 2023 Advent of Code, and we're finally off the desert island and onto the metal island. I read through the task and it is kinda complicated. We have some kind of a grid of pipes and we have 6 possible ways of pipe. One that is basically not a pipe and one special that is the starting position. And the starting position basically always masks a pipe. So now we have that this pipe has to be an F pipe. Unfortunately, we're not going to be given only our nice pipes that we want, but we're going to be given a lot of unneeded pipes. Our task is basically we're starting from the starting pipe and to see which part of this cycle is furthest away. So we have a loop of 1, 2, 3, 4, 5, 6, 7 elements that are going, actually including this one, 8, that are going round and round. And since it is an even number of links in that chain or then in that loop, we know that the J1 is actually the furthest away because we are free to go one way or the other. So all of them, we can reach these two in 1 step, these two in 2 steps, these two in 3 steps, and this one in 4 steps. But we're not giving that input, we're giving something like this as an input. And now we need to determine whether we have what kind of a pipe our S pipe is. So the first task will be something like that. What kind of a pipe is our S pipe? And in this case, since this doesn't have, and once more, they're giving in the terms of north, south, east, and west, I'm not going to use that. I'm going to use top, bottom, left, and right because I sometimes mess up left and right, and I definitely going to mess up east and west. So this one on top of it there is an L pipe. An L pipe doesn't connect to the bottom. An L pipe connects to the top and to the that's left, that's right, and to the top and to the right. Anyway, it doesn't connect to the bottom. So this is not a connection. Same logic goes for the 7 pipe, which means our S pipe, and each of the pipes has exactly 2 places where it connects. So we don't have any junctions, we don't have anything else, we don't have T-shaped pipes, we only have the 6 types of pipes that connect on exactly two dots on the map, on the grid. So our S pipe can only be connected with this, and if it's connected with that, it has to be a F pipe, I think. Yeah. So we have another example here, slightly more complex, and here we have our S pipe, but with some non-main loop. Here it's easy because it has to connect to the J pipe and the pipe. So what I will actually do, first I want to determine whether our S pipe, and this is the input that we're gonna use, and you can see there are lots of pipes here. We need to find our S pipe and see whether we can uniquely, yeah, there's exactly one. We can uniquely determine to which pipes it connects. Well, next to it, there's a pipe. Actually, on the right of it, there's a pipe which does not connect to the left. So that means that is not an issue. So underneath it, we'd have a 7 pipe, which connects to the left and connects to the bottom. Let's check this out. A 7 pipe connects south and west to the, yeah, that way. So this one also cannot be part of our S, so it means we have an F pipe and we have a 7 pipe on top. So we're gonna run an assumption that's sustained by this input that there is a unique way how our S pipe connects, which means that we will be able to actually determine the type of pipe, one of these six, that our S pipe is. So we have this thing as an input. Let's try it on. And then we'll have this thing as well as an input. And for the first test input, we're gonna need to have a 4. And for the other one, we're gonna need to have a 8. Okay, so let's start. So first of all, let's copy over this thing. It's a 5 by 5 grid, and we're gonna need to process it. How I will process it? One thing that I really hate about this kind of tasks, that we're gonna do a lot of number management, which says increase x by 1, decrease y by 1, things like that, which are very, very easy to get wrong. So I will actually try to have to defend against that, maybe by using some types. Let's see. So we have a pipe. Yeah, we have a pipe that has, okay, I'm gonna use kind of an explicit thing. So this will be a character, which is a string. How, which character represent that pipe? We're gonna have an X, and we're gonna have a Y. Let's have them as well. And we're gonna have a top, which is a boolean, a bottom, which is a boolean, a left that's a boolean, and a right that's a boolean. And I will also want to have something along these lines that's type pipe. That's actually a vertical pipe that connects to the top and to the bottom. So this will have a top true, bottom true, left and right false. And let's have a dash pipe. Yep, actually not pipe dash, but dash pipe. That's a horizontal pipe that connects to the top and the bottom, or that doesn't connect to the top and the bottom. And then we're gonna have a, not a left pipe, but we're gonna have an L pipe. And I will call it like this, L pipe, that connects to the north, to the top, and to the east, which in our parlance is the right. So to the top, it doesn't connect to the bottom, it doesn't connect to the left, and it connects to the right. R pipe. No, we have a J pipe. And a J pipe connects to the north, which is the top. Actually, I will just put in everything that's false first. To the north, which is the top, and to the west, which is the left. No, we don't have a T pipe. Actually, let's define one type that's gonna call no pipe. That's actually doesn't connect to anything. No pipe, 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 dash pipe, L pipe, J pipe. and the next one is a 7 pipe, and that connects to the south, which is bottom, and the west, which is left. So we have bottom and we have left, and we have the F pipe, which connects to the bottom and connects to the right. And now we have all these pipe types, which means that we might be ready to actually process the input, and we just need to get some kind of maze, which will be a array of pipes. So I'm just gonna do a for of loop for each line of lines, and another for of loop for each character of line, since that's a string, and char would also be a string, but that it will be a one character thingy. So we're gonna say the row is a pipe array, and then at the end we're gonna add the row to the pipe. And in the meantime, for each character, we're gonna need to determine which kind of pipe it is and then create such a pipe. So this is gonna be very long and very ugly code that we're gonna need to write, but there's just no helping it. And to be honest, I kind of prefer if my code is a bit longish than a bit too clever, because we could just say if it's this or if it's this, then it has a left which is true, and so on and so forth. But no, I will just go full on. If the character is a dot, then we need to push. That's the character, and this thing says a new no pipe, but unfortunately no pipe is not a thing that we have. It's not a class, it's just a type, so we're gonna have to actually spell it out. Top is false, bottom is false, left is false, right is false. And I will say as no pipe here. And in that case, it will just say, oh, but no pipe is not a pipe. We can say that this is a pipe, and then it will work, but then we have no type checking. And I actually want to do that. So I will do something more actually. Maybe not use this interface. Let's add another interface that I will call point. And it will have an X and a Y. And then no pipe is this and the point. And it will have a character that is a dot. This is not strictly necessary, the character, but we might want to display after the map that we have. And now it says no pipe is a pipe, because it has all the types that the thing needs. And else if the character is actually a pipe, that's the character, that's the X, that's the Y, that's us, pipe. Is it a pipe? No, because now we just need to add this to all the pipes. That's a pipe, that's a dash pipe, L pipe, a J pipe, a 7 pipe, and an F pipe. So this is property character is missing. Yeah, we need to add those as well. The character is a pipe, the character is a dash, the character is an L, the character is a J, the character is a 7, and the character is an F. Yeah, now it's okay. But I think I kind of messed up because x and y don't have to always be 0, so this is not a for of loop, this is a for loop. And it's the full format, only that's the not the C index, but this is the X. Really? Is it the X? No, that's the Y. That's the Y. Come on, something broke. That's the Y. And Y is less than the lines dot length. And then we increment the Y. And we have our line that is lines of Y. Sometimes this works beautifully, sometimes it doesn't. So instead of this, we're going to have another for loop that says x is less than the line dot length. We're going to increment the x, and this is the check character. And everything else is the same, only we can do this, and this, and this, and we can actually rename this to character. And now we can just say, well, we don't need this part. Else if it's a dash, we have a dash pipe. Else if it's an L, we have an L pipe. Else if it's a J, we have a J pipe. Else if it's a 7, we have a 7 pipe. Else if it's an F, we have an F pipe. Else, let's just throw an unknown character right now. And let's see if this is operational. We just don't need this line now. And this is not lines, it's line. So seems to be okay. So if we wrote this thing correctly, we might get a error for the S, because that's the only character that we haven't covered. Unknown character S. Great. So for the S, we're gonna have actually a special type. Why not? Since we have no idea what the S is, I'm just gonna copy this over and call this a start pipe. And the character is an S, everything is false, and we actually have that. So yeah, we're gonna keep this thing because we don't want to, but we can do else if the character is an A, then we say that everything is false. So this is some ugly and terribly specific code, but it might give us, it might run actually for now. So it's running. We're not returning anything out of this. So we just have our maps, which is a set of pipes. But what will the actual input be? So we have the pipes and we have the location of the start pipe. Because we gonna need that. So we will also have let start, which is a start pipe. And then additionally here we will just say that the start pipe is this. We don't even need this since this is a start pipe. start. And now we can enter the start. Note that now we are sure, because if we say that through here, it will say, nope, you can't do that. So we have a little bit of type safety. So now we can just return this thing. We have our pipes and we have our start. So we can say the pipes is the maze and the start is the start. And we need to return that maze. Yeah, this thing doesn't definitely assign. What happens if we don't have an S? Yeah, we're gonna hack it a little bit. Right now we're saying this is not a start type, but make believe that it is a start pipe. And now it says, okay, if you say so. We're gonna need to change this into a maze. And at the very least, our thing will compile input.pipes.length. Or we can just say return -1, since that is a known incorrect value. Does this thing works? Do we create a maze? We seem to. And let's just console log it. We're gonna get a bunch of data, but I'm curious whether we get the correct X and Y for the S character, which should be 1, 1. So it's on 1, 1, and for the pipes, we have our matrix here with a lot of objects. So the first thing we're gonna do is we're gonna actually need to replace the start pipe in the maze with the actual start pipe. So let's say const actual start pipe is get a start pipe of a maze. So that will be a function that, yeah, this is a default implementation and not the one that we actually want, but it is an implementation. So once more, we're gonna need to have some extremely ugly and repetitive code here. There will be a lot of code that we're gonna write, and it always, this kind of task generate a lot of code, but fortunately, most of that code will be generated by Copilot for us. We're just gonna need to look through it. So we have a few options right now. Let's see, we're gonna need to determine, does the top match? And then we're gonna need to, does the bottom match, does the left match, does the right match? And based on whichever two of these are matching, we're gonna need to generate such a pipe to actually replace it. So, does the top match? The top matches. So, let's see what's the top of this. Is this thing. Yeah, the one that is above that. So, this will be a pipe. Now, since we're going y -1, this means that we might, if the top is on this line, this might be null. So we're gonna need to write something like this. If this is null, actually let's make it a 2 liner. That's the top row. So if the top row is that it exists, return top row of this. We don't care about whether this is null. Okay, in this case it cannot be because it is actually here, otherwise it's null. I want to leave undefined for actual undefined things. So top will be a pipe or null, and we can say const top match is if the top matches and the top has a connection to the bottom. Otherwise, we have the bottom row, exact same logic, exact same logic. Only for the bottom, we need to have a connection on the top. That's the left match. So, for the left, we actually don't care, because if this goes off the array, we're just getting an undefined. So, we're just gonna need this, that's the right match, is this. So now we know what matches. And now we can say if the top and the bottom match. Actually, I might write this like this so we can have something like this. So we have 6 different options now. No. And we know from the way we discuss the input and look through the input that we are gonna have something that matches on only 2 sides. So if the top match and if the bottom matches, we know that the left and the right should not. We don't need that. So if the top matches and the bottom matches, then we just return a pipe. Pipe. Actually, I will do it. Const result equals, which is a pipe, and then return the result, because I do want that type safety, because I have a feeling that otherwise I will have a error here. Yeah, and that's exactly what we want. The character is a pipe, the X is over there, so yeah. So if it's not a bottom match, then it could be a left match. And if it's a left match, so we have on the top and on the left. Oh, if we have a match on the left, this is smart. I would have made an error. Actually, if we have a connection on the top and on the left, we need to have a connection on the top and on the left. So this is true, this is false. And now this says this cannot be because this is not an L pipe. This is gonna be a J pipe. The J pipe has the connection on the top and on the left. Doesn't actually look like that. Let's take a look at the input once more. I might have missed some. North and west. Yeah, basically what we actually need is an inverted L, and it seems that the J is the closest thing to an inverted L. Inverted this way. And for an F, we need it inverted this way, and for a 7, we need it inverted this way. So, yeah, okay. Let's call that a J. So we can match on the bottom, we can match on the left, else we can match on the right. And this thing really wants this to be a L pipe, and in this case it is an L pipe. So we have three combinations here, and those combinations won't match. So if we don't match on the top, but if we match on the bottom and on the left, then it is an F pipe, bottom and left. Is it an F pipe? No, that's going to be a 7 pipe. So let's look at it one more. It matches on the left and on the bottom. So that's a 7 pipe. And this is an F pipe, I think. So we're gonna have the character 7 and this is gonna be true and this is gonna be false. So an F pipe has an F and this is false and this is true. And if we get here, that means that we didn't match on the top and on the bottom, but we did match on the left and on the right, so we have a dash pipe and we're returning a result. So if this totally ugly if succeed, that means we have something that has, well, in our case, at least 2 matches. We're going to return if it, even if it has 3 matches, but yeah, what can we do? So let's just console log the actual start pipe. So for our input, this is going to be a F pipe, I think. So yeah, we're going to need to make it into an F pipe. Let's see if this works. We should get an F pipe back. And this is why I added the character, otherwise it would have been this is an I think. So it is an F pipe. But what happens if we change the F pipe and say that this is the start pipe? We should get an L pipe. No. Oh. Yeah, we should get an L pipe, but because this is a pipe. So let's change something into something else. Let's change it into a dash. I don't know. The other one, no. We're gonna change that into a dash and this into a pipe. And now it should be correct. Yeah, we got an L pipe back. Otherwise we had too many matches. So let's say if we change this into the start position and this is a dash. So to avoid any extra matches, this should become a J. Yeah. So this is an F. Oh, this is an F, and instead of a 7, this is the starting position, but this is a dash, and that is a pipe. To avoid, basically to detect all the other possibilities, so we should get a 7. Yep. And if this is the starting position and this is a dash, and this is a dash as well, again, avoiding wrong, impossible starting position. We got a dash, so yeah. And if this is an F and this is an S and this is a pipe and this is a pipe as well. So we changed it everything and we should get a pipe as the answer because it's connected at the top and the bottom. So it seems that our start pipe detection is actually running in a terribly long and winded way, but it is running. So what we need to do now is to actually replace that pipe inside our input. So we're going to say input dot pipes of that is the actual start pipe. And now we need to make our loop. One thing that is not obvious and definitely not stated in the problem is that we don't actually need to find the position. But what we actually need to do is get the loop length. And if we get the loop length, then it's totally simple because the furthest away will be exactly half of the loop length. So if we have a loop of length 8, the furthest away, the most steps away will be 4. If the loop is of length 9, again it will be 4. If it's 10, it's going to be 5. So this means, since we have an 8, that the total loop has the length of 16? Yeah, 16. We have two ones, two threes, and so on up to sevens, and then we have 1, 0, and 1, 8. So we're gonna just need to start from the start and loop until we get to the start again. So we're gonna start from the start. So let current pipe is the actual start pipe and let direction to be down. Yeah, so we're gonna need the directions as well. No up, down, left or right, but I will reuse the terms that we were already using: top, bottom, left and right. So the direction is actually of type direction. And that's going to be bottom actually. And I will just ensure that the direction is something that the current pipe has. So if direction, if current pipe of direction, and note that this is valid because the current pipe direction can only be one of the properties that the current pipe has. And I will actually add this const next direction, which will be something that gets a direction and returns the next direction. And it's just gonna be a simple round robin thing. So if, yeah, but it's not gonna be like this. It's gonna be a bit different. Because if we go this way, we are changing top for bottom, and then if we're changing bottom from top, so top never becomes left. And we want to go into a round robin way, maybe clockwise, maybe counterclockwise, I have no idea, but we need to go through all four of them. So if we get here, we're just gonna throw with an invalid unknown direction. But even the compiler says, if this is a direction, you're not gonna get here. Let's leave it here. Sometimes it might be possible to do stupid things. So if it's top, we're gonna go right. If it's right, we're gonna go bottom. If it's bottom, we're gonna go left. And if it's left, we're gonna go top. So that means if we start from the top or if we start from the bottom, we're going left and then we're going to the top and then we're going right and then we're going to the bottom. So we need the current pipe and a direction that it's connected. So we're going to start with, let's start with the top. So while current pipe of direction is not true, So while the current pipe is not connected, well, try the next one. And let's see this. So in our first case, our start pipe is not connected to the top. It's connected to the left, right, and the bottom. So we should actually start growing from the top. We should start going right. So we should get that we're starting at the start point, going right. Starting at F, going right. Yeah, that's okay. Let's add some more data, like current pipe X and current pipe Y. Starting at F11, going right. And now we just need to loop. And while the current pipe is not the actual start pipe, we're gonna need to actually loop. But the current pipe is the actual start pipe, which means it might make sense to actually make a single step and calculate the next pipe. And I will again, since this is gonna be some ugly code, make a function, get next pipe. And it's gonna be something like this. Let's see if it is correct. If we're going to the top, we need to get y minus 1. If we're going right, that's that direction, x needs to increase. Bottom, y needs to increase. Left, x needs to decrease. We might run over. No, we should not go overboard, because our cycle should never have a situation when we go to this thing and we need to proceed left, because that's not a good cycle. That's a broken cycle. And the input promised that it won't have broken cycles. So the next pipe will be get next pipe. So we will have a technique here that is usually called a loop and a half. So we're gonna have some of this code inside the loop as well. So while the next pipe is not the start pipe, and we're gonna have loop length here, which is gonna be, well, we're gonna start at 1 because we already did the next one. We'll see whether we need to add 1 at the end. So while the next pipe, we're gonna increase this, and the next pipe is pipe. And we seem to have some piping issues because the current pipe is actually all of these pipe types possible, and the next type is actually a general pipe. But we redefined this interface so many times that I don't think that we actually need it now. And we can just say that the pipe is something else. It's actually this thing. It's either of those pipes. So we will have a specific pipe type, and this says, oh, but then it cannot be a no type. And we will need to specify that we're gonna return a pipe. Or we can have yet another type, but to be honest, I think that this is good enough. We can always add more types and make it more type safe and more constraint and whatnot. But in this specific case, I want to use the types not to make a perfect program, but to make a program where I'm less likely to actually make mistakes. So, if the next pipe is not the actual start pipe, we're increasing the loop length by 1. We're saying, well, move over to the next pipe. The current pipe becomes the next pipe. We are getting the next direction. And then we're going that. And this will be wrong. Because we already know that the current pipe has this direction, but we need to find the other direction of the current pipe. Because we are starting at F going right. But then what will happen is we're starting here going right, and then we go right, and we need to go, we're saying we are going right. And if this is okay, then we're gonna go right, so this will work. And then we will come here and say we wanna go right. And itself we cannot go right here, because this thing doesn't have a right. And we will get the next thing, which is go to the bottom, and this will go to the bottom. And this one will go to the bottom, and this one will try to go to the bottom. And in this specific case, I think that we will actually solve this. Yeah, let's do this. I know that this is the wrong code, but I think that it will actually work here. Continuing at going in that direction. So let's see where we go. And it's quite possible that we get a compile error because we didn't change something else. It says that part 1 is wrong. Why is part 1 wrong? Because it doesn't return. Yeah, we usually forget that. So return loop length divided by 2 and use the floor. That's the actual value. But we're not actually interested in the value itself. We're interested in the path it's gonna take. So we're starting at F, continuing at the dash. We arrived at the 7, continuing at that thing, and the pipe, J, dash, L, up, going top. And yeah, the up and down might have been better names than top and bottom, but I'm not going to change them now. And we increased it 1, 2. So yeah, I think that we needed to start at 1. We increased it 7 times, so we got 7. And we needed to actually to get 8 because the start is also part of the loop. So now the answer will be 4. And this is the correct answer. But this actually only makes sense is if our loop is kind of consistent, kind of circle-like. And if it's some twisty thing like here, it won't do the job. So the more complex loop with everything added. Let's here the start is actually F. Yeah, it's F once again. And I'm quite sure this will go off the rails. So starting at F02, that part is correct. Going right. And then it got to this thing, which is supposed to go up. But we were going that way. We were going right. Right. And then the next of the right was bottom. And it cannot go to the bottom. And the next to the bottom is left. And it says, yeah, I can go left. So it actually went left. So what it did was it went here and then says, well, I'm returning back. And that's what can happen if we don't have a circular loop. So that's what I mean by this code actually being wrong. So we don't need just any direction. We need any direction available to the current pipe, which is not the direction that it came from, which is not the inverse actually of the direction of that it came from. So, which means we might need this method as well, get inverse direction. Yeah. So for the top, yeah. So it doesn't really matter. We need in which direction we were going. We actually need to find the other direction where it is, and this is quite a nice loop. And we need to make sure const restricted direction. That's the inverse direction. So we need to find any direction in the current pipe which is not the restricted direction. And if the restricted direction is the restricted direction, when loops once again. So this means continue from any direction and the current direction is just as good, and trying to find the other one. So we're going left, try to find the other one. So we're going bottom, no. Left, no, that's the restricted one. Top, top is okay. So this might work better. Let's see what happens now. And let's take a look at this. So we're starting at the S, which is an F actually. And then it says we're continuing at the J. Yes. And then we're going to the F. Yes. And from the F, we're going to need to go to another J, which goes to another F, which goes to a 7, which goes to a pipe, which goes to an L7J dash dash FJ L pipe. And we got to that, and the result is looks okay. So I'm just gonna remove these console loop logs and try with the huge input. See if this actually provides some kind of a result. We don't need this line, and even if we did, it's not gonna be any kind of problem because we're just not visiting any pipes that are not on the loop. So we were able to actually do a lot of things that are kind of iffy, but they're working for us. Let's see what does Advent of Code say, whether 7,000 is actually half of the loop length. So that means that we have a 15,000 step loop pipe. That is correct. So we need to take part 2, and I'm kind of scared to click this. Let's continue it in part 2 of this video.